All right, let's dive right in. Today we're tackling a core concept in Kubernetes, and it's a big one. Why you should almost never, ever run your application as a standalone pod. We're going to uncover the powerful safety net that professionals use to keep their apps alive and kicking. So, you did it. You containerized your app, you got it running inside your Kubernetes pod. It works. You might think, great, I'm ready for production. But hold on. That's a super common misconception, and it's a trap you really don't want to fall into. Let's break down why. You see, a pod all by itself is, well, it's fragile. It has absolutely no recovery plan. If a server crashes or someone accidentally deletes it, poof, your application is just gone. There's no automatic restart. For any real-world app, that's a total deal breaker. But don't worry, Kubernetes gives us a much, much smarter way to do things. To really get this, let's use an analogy. I want you to think of Kubernetes as a fully automated factory floor. This little metaphor is going to make it crystal clear how all the different layers work together to keep your app running perfectly. Okay, so at the most basic level, we have the container. This is our factory worker. It's your app, all packaged up. You'd normally run it with a Docker run command, telling it what ports to use, and so on. It does its one job, but it's totally on its own. Now, Kubernetes takes that little worker container, or maybe a few of them, and wraps them up into something called a pod. You can think of a pod as a workstation. This is already a big step up because now the containers have a shared space. They can talk to each other on localhost, share files, and it's all defined in a nice, clean YAML file. But here's the catch, and it's a big one. This workstation, it's still all by itself. It's a nice little package, sure, but if it breaks, it's broken. It can't heal itself, and it definitely can't handle a sudden rush of new work. It's missing those key enterprise features that make Kubernetes so powerful. And that brings us to the hero of our story today, the deployment. The deployment is our factory manager. Its job isn't to do the actual work. No, its job is to oversee all the workstations, all the pods, and to make absolutely sure they are always running exactly the way we told them to. This table just lays it all out perfectly. Look at the recovery and scaling rows. For a container or a pod, what does it say? None and manual. You have to do everything yourself. But for a deployment, auto-healing and auto-scaling, the manager handles it all. That's the game changer for running a real production app. So you're probably wondering, does this factory manager, the deployment, personally run around and check on every single pod? Well, not quite. Like any good manager, it knows the secret to success is delegation. You see, the deployment uses a secret weapon, a powerful resource that acts as its trusted supervisor on the factory floor. This supervisor has one job and one job only, to enforce the manager's orders without question. This supervisor is called a ReplicaSet. It's a type of Kubernetes controller, which is really just a program that's always watching. It's constantly comparing the state you want, say, I want 3 pods, with the state that actually exists. And if they don't match, it fixes it immediately. And here's that chain of command in action. The deployment, our manager, sets the goal. It then hands that order off to a ReplicaSet, its supervisor. And the ReplicaSet does all the grunt work of creating, watching, and maintaining the pods. You, the operator, you only ever have to talk to the manager. Pretty neat, right? So this whole manager-supervisor setup is what gives our applications some serious superpowers. Let's check out these so-called enterprise behaviors in action. First up, and honestly this is my favorite, is auto-healing. Let's see what happens when a pod just randomly disappears. This is where the real magic of Kubernetes shines. Okay, so imagine the manager's order is, we need 3 pods running, always. But then, poof, one of them crashes or gets deleted. The ReplicaSet supervisor, which is always watching, sees this mismatch instantly. It's like, hey, the boss said 3, but I only count 2. And boom, before you can even get an alert on your phone, the ReplicaSet springs into action. It spins up a brand new, identical pod to replace the one that was lost, bringing the count right back to 3. Your application just healed itself, and nobody even noticed. All right, next superpower. What happens when you suddenly get a huge spike in traffic? Well, instead of panicking and manually trying to launch new servers, you just give the factory manager a new order. You just go into your deployment's YAML file, you find one little number called replicas, change it from 3 to 5, and apply it. That's it. The ReplicaSet sees the new order and immediately gets to work, creating 2 more pods to handle the load. Scaling up or down is literally that simple. And this one is absolutely crucial for modern applications: zero downtime updates. When you need to roll out a new version of your app, the deployment is smart. It performs a rolling update, meaning it brings up the new pods before it takes down the old ones, ensuring there's always something available to serve your users. They won't experience any downtime at all. So, how do we, the operators, actually talk to our factory manager? How do we give it these orders? We use the command line tool every Kubernetes pro knows and loves, kubectl. What's really cool is how these commands map right back to our analogy. Kubectl apply is you handing a new blueprint to the manager. Kubectl get all is like asking for a status report of the entire factory floor. And my personal favorite, get pods-w, lets you literally watch the supervisors and workers in real time as they're created and destroyed. All of this brings us to the most important takeaway of the day. This is a direct quote from our source material, and I want you to burn it into your memory, because it is the guiding principle for running reliable apps on Kubernetes. This is it. This is the golden rule. You always use deployments. They give you the auto-healing, the auto-scaling, and the safe updates that are non-negotiable for any serious real-world application. Stop trying to manage individual workstations. Be the one who manages the whole factory. Okay, so now our application is a fortress. It's resilient, it's self-healing, it's scalable. But it's also kind of trapped inside the cluster. The next logical question is, how do we let the outside world actually use it? Well, that is a story for our next explainer.